Okay, so this is the review session for the coordinate proofs test. And we're going to start by looking at this sheet, which you did in class. This is for this was from section 6.8.6.9. This is not working. Okay, all right. Well, my pen's not working. Oh, there we go. 6.8.6.9. Practicing putting the polygons, mostly quadrilaterals, right, onto a coordinate plane using variables as the coordinates. Remember, if you were asked to write a coordinate proof, there are no numbers. We're not using numbers. We're not saying over 6 and up 10, right? You're using variables, A, B, C, whatever, okay? So if you are given a proof that says prove that, the diagonals of a rectangle are congruent. Your first job is to draw a rectangle on a coordinate plane. So this worksheet was just practice putting the coordinates on the coordinate plane in a way that makes it the shape you want it to be. If you want it to be a square, all the sides have to be the same length, right? So these coordinates make sense. If we nestle it into the corner of the two axes, that's a right angle, it makes it a square. We go over A and up A to here. This is over A and up 0. This is over 0, up A. So that makes it a square. So if we need a square, that's the way we can put it on the coordinate plane. This is all off. Okay, rectangle is next. Oops. Right, so it makes sense to either straddle the y-axis so that you know you're going over A and back A, and then up B. That makes them two different lengths. Or nestle it into the corner of the axes again, over A, up B. That makes it a rectangle because they're two different lengths, and you have that right angle of the axes there. When you come down here, remember, with an isosceles trapezoid or with a parallelogram, when you have these diagonal type of slanted, pieces there, sides there, you have to remember that this little piece and this little piece have to be the same length if it's an isosceles trapezoid. So your coordinates have to reflect that. So if this distance is A right here, and the green distance is B, then to get to this point over here, it's A plus B. You go over A plus B to get to that point, and then up 0. But to get to this point, it's over A and then up C, and that gets you to there. So all of your coordinates need to make sense. Here, again, I have the y-axis as the line of symmetry. Here I have the origin as a vertex on the trapezoid. I designated this green distance as A. So to get to this point, I have to go A plus B and up C. So to get to this point over here, let me use another color, blue point, I have to go over A plus B plus another A. So that's 2A plus B. Again, there's different ways of doing this. These two ways that I did it are not even the only two. There's other ways to do it too. The next one is a trapezoid that's not isosceles, so I need another variable in there because this distance has to be different than this distance. Let me make that a different color since it's a different distance, right? Those two should not be the same because if they are the same, it's going to make it isosceles. And this specifically says not an isosceles trapezoid. Or if it just says, like if the proof just says trapezoid and doesn't specify isosceles, you have to assume it should be not isosceles. Because every time you do a proof, you don't want it to be about something too special, more special than what they're asking you to do. Okay, so these answers are posted online, and so you should check those. And then there's a coordinate proof down here. Let's look at this one, number 10. The quadrilateral formed by connecting the midpoints of a kite is a rectangle. That's what we're trying to prove. Write a coordinate proof of the following. So prove that the quadrilateral formed by connecting the midpoints of a kite is a rectangle. So the first thing we have to do is draw a kite onto a coordinate plane, right? So you have to create the coordinate plane, and you have to create the kite. Kites make most sense going through the origin as the intersection of their two diagonals, because the diagonals of a kite are perpendicular. So it makes the most sense to put those through the origin as the diagonals, right? And then for a kite, you're going to want to go, up a certain distance. In this case, up 2b, because I had to use midpoint, so I made it 2b instead of just b, right? And then you want to make sure that this distance is a different distance. Otherwise, your kite will look more like a rhombus, right? And you want this distance this way, I'm running out of colors here, this distance this way to even be different than those two. So that's why we have A, B, and C here. So this is up A, oops, wrong color. This is up A, up B, couldn't read that, up B, right or left A, and down C, and that makes it a kite. So first job is to draw the kite. Then it says, prove that the quadrilateral formed by connecting the midpoints. So the first thing you have to do is find the midpoints of this kite. So if my kite is K-I-T-E, my quadrilateral formed by connecting the midpoints is going to be called something else. I think I called it X, Y, Z, W. Oh, I guess I have A, B, C, D, right. Okay, my kite is A, B, C, and D. That is my kite, A, B, C, D. So the midpoint of AB is point X. So I used the coordinates that I came up with here for A, B, C, D, and I used the midpoint formula, and I came up with a set of coordinates for X, a set of coordinates for Y, Z, and W. So now these are the coordinates that I'm working with, right, for proving that that quadrilateral is, what's it say, is a rectangle. I have to prove that it's a rectangle. So then we have to think, how do we prove that something is a rectangle? Everybody have ideas? What's special about a rectangle? That if we can show that this quadrilateral has certain properties, we know for sure that it's a rectangle. Yeah, what do you think? Diagonals are congruent, or each angle is a right angle. Exactly. So either way, we have to show that if we're going to show the diagonals are congruent, we have to show it's a parallelogram first. Can't go straight to diagonals congruent. Show it's a parallelogram first, and then show the diagonals are congruent. Or you can show that all four are right angles. So that's two different methods. You don't have to do all of it. Two different methods. If we use Evelyn's method, we're going to prove it's a parallelogram first. So diagonals bisect each other is going to give us the fact that it's a parallelogram. With the least amount of calculation. Now we could do opposite sides parallel, opposite sides congruent, one pair of opposite sides congruent and parallel. We could do any of those to prove it's a parallelogram, but all of those require 4 calculations. This one requires 2. Diagonals bisect each other. You take the midpoints of the 2 diagonals, right? If we take any parallelogram and we find the midpoint of the two diagonals. If the midpoint is the same for each diagonal, then it's a parallelogram. So in fact, using these points that these vertices that we have, it turns out that the midpoint of each diagonal is the same. Therefore, it's a parallelogram. So we establish it's a parallelogram, then we can show that the diagonals are congruent. That would require distance formula 2 times. Diagonals are congruent. Turns out they are. And then we're ready to make our conclusion. Since it's a parallelogram with diagonals the same length, then the quadrilateral that is formed is a rectangle. Okay, so that's what a coordinate proof is all about. Now, I know that you guys have some of you have gotten this and some of you haven't, but I'm going to give it all to you again. Do you have this? I'm not sure if you have it or not. Some classes got it and some classes. I think you have this already. Okay, so this worksheet is a good practice actually writing your own coordinate proofs, okay, which is what you're going to need to do when it comes to the part 2 of the test. Okay, so I know you know the midpoint formula, distance formula, but here we go. This says prove the diagonals of a parallelogram bisect each other. That's it. Just prove that the diagonals of a parallelogram bisect each other. So the first job we have to do is draw a what? Parallelogram. You must make this a general parallelogram. You cannot make it a rectangle or a square or a rhombus. You have to make it a parallelogram. That isn't special. Okay? So that's going to be like we did on that other sheet. That's going to look like, you know, this. You don't have to draw it exactly how I draw it, but it's going to look something like that. Okay? We've got this point at 0, 0. When you are creating your diagram, okay, it needs to be logical. So we want to make our coordinates here logical. Why doesn't everybody try to make coordinates? Make it a parallelogram. Remember that with a parallelogram, this part right here has to be the same as this part right here. That's what makes it a parallelogram. Those distances are the same. Okay, I'm going to pause and let you guys try this on your own. Okay, so here we have the coordinates. Magically appeared. You got to make sure that the yellow distances are the same. So my whole distance here is B. So that's B0. And then this vertex was B plus the yellow distance A, and then up C. Okay, so no matter what your coordinates are, they might be different than mine. To prove that the diagonals bisect each other, I give you a hint here, show the midpoint of the diagonals are the same point, right? So you're going to use the midpoint formula. Remember, always write out what formula you are using as part of your proof. You have to label your formulas. Make sure you are treating this proof as an explanation to somebody who isn't really going to have to work too hard to follow your logic, namely me. I need to follow your logic and be able to give you credit for what you've done. So the midpoint formula to find the midpoint of the two diagonals. Well, let's call this maybe A, B, C, and D. I'm going to find the midpoint of AC, that's one diagonal, and of BD. So the midpoint of AC, I'm going to do x plus x, right? So the x coordinate here plus the x coordinate here. So that's b plus a over 2. Sorry, b plus a plus 0 over 2. That's adding the x's. Adding the y's, c plus 0 over 2. When you simplify that, and you should always simplify, b plus a over 2, comma, c over 2. Now, if you were smart, you made everything double, and you didn't get anything over 2. Knowing that you find the midpoint, you could double everything. In this case, we don't have a lot of algebra to do with this, so not doubling it isn't as consequential as it could be. But there's our one midpoint. Now we're going to do the midpoint of BD. So we've got these coordinates and these coordinates, a plus b, that's adding the x's over 2, and c plus 0 over 2. Either way, this is the same as the one that we got before. Right? Same midpoint means we have proven that the diagonals of a parallelogram bisect each other. Right? Does that make sense? That's it. That's all you needed was two diagonals, two midpoint formulas. Remember, you need to make a conclusion. Since A, C, and BD have the same midpoint, then diagonals of a parallelogram bisect each other. And that's what we were trying to prove. Okay, the second one here, prove that the diagonals of a rhombus are perpendicular. What's the first thing we have to draw? A rhombus. I recommend, there are some that I just recommend, you know, squares and rectangles and parallelograms and trapezoids, you've got a lot of options with. But when it comes to kites and rhombuses, I would make the diagonals, since diagonals are perpendicular, right, I would make it so that the diagonals are intersecting right around that origin. So this is going to be guaranteed to be a rhombus. You go left or right one direction and up and down a different direction, it's still going to be a rhombus, no matter how far in any direction you go. Okay, so I definitely recommend for rhombus that this is the way you do it. There are other options, but this is what I recommend. It's going to simplify your life a little bit. Okay, so fill in those variables the way you think you should. Okay, so again, your coordinates might be different than what I have here, but they should be the same idea, right? Since we've put the origin as the center of the intersection of the diagonals, you're going to go over 0, up a distance, over 0, down a distance. So to get these 2 points, you might have a different letter, but that's pretty much what it should be. I used A and B here for my 2 different distances. Diagonals of a rhombus are perpendicular. What formula are we going to use? Slope formula. So we need the slope of the diagonals. Slope of BD and slope of AC. when we do slope formula, we do the difference in the a's on top, I mean the y's on top, so a minus a negative a, that's plus positive, over 0 minus 0. And I get 2a over 0. What is that slope? What would you call that if it's over 0? What do you call that? What? It's okay, it's an undefined slope, which makes it a vertical line. You're both right. Yep. So this is an undefined slope, right? You can't have 0 on the bottom of a fraction. So it's an undefined slope, which makes it a vertical line. Which, if we look at our diagram, in fact, BD is a vertical line, right? We can see that there. So it's a vertical line. And then we do the slope of AC. I'm going to have 0 minus 0 on the top, and negative b minus b on the bottom. And I get 0 over negative 2b. 0 over anything is 0. So now we have an undefined slope, and we have a 0 slope. What kind of a line is a 0 slope? Horizontal line, right? 0 slopes can be horizontal line. Any vertical line and any horizontal line are perpendicular to each other. So we've just proven that the diagonals of a rhombus are perpendicular. We would have to write a sentence, remember, to do that. If we look at the back, I know some people have to go, but if we look at the back, we're proving, number 3, the segments joining the midpoints of the sides of a rectangle form a rhombus. Okay, if you have to go, just remember to look at the video of the review packet explained. Okay, did you guys get the review packet yet, your class? No, you're going to get that tomorrow. Yeah, but remember that it's all explained online. Okay, and then part 1 is 1738, sorry, 1737, 38, and 67. And then part 2 is 68 and 69. Okay? All right. See ya. Okay. Segments joining the midpoints of the sides of a rectangle form a rhombus. So what are you drawing first? Yeah, but what's it going to be? Okay, so we're going to have to start with a rectangle here. And we know we have to find midpoints. So probably if we use 2 times the variable, we'll have better luck with finding the midpoint. Okay, again, your coordinates might be different than mine. And since, like I said, we're going to be doing a midpoint, you probably want to put a 2 in front of everything. Even if you add it as an afterthought, it's okay. Okay, so we started with a rectangle. Now we need the midpoints of the sides of the rectangle. So we're going to get the midpoint. Again, label what you're using, what formula you're using. Midpoints of sides AB first, and then BC, CD, and then AD. Add the x's, divide by 2, add the y's, divide by 2. So AB, I'm doing 0 plus 0 over 2, and 2b plus 0 over 2. So this simplifies to 0, comma, b, which makes sense. BC is going to be 2a plus 0 over 2, and 2b plus 2b over 2, and that's going to be just a, comma, 2b, because it's 4b, right? 4b over 2 is 2b. And then C CD is going to be 2a plus 0 over 2 and 0 plus 0 over 2, which is just a comma 0. And then AD, did I do that wrong? I just did AD, didn't I? This one was AD. 2a plus, did it wrong. Sorry, I did AD instead of CD in this last one. So CD is 2a plus 2a over 2 and 2b plus 0 over 2. So that's 4a over 2 comma 2b over 2, which is just 2a comma b. And then the last one, I should have just moved it down, is going to be 2a plus 0 over 2 and 0 plus 0 over 2, and that's a comma 0. So we have our midpoints now. We could rename these so that we have variables x, y, z, w. Midpoint of AB, that's x, y, z, w. All right, so we have to prove that the segments joining those midpoints form a rhombus. So how are we going to prove something is a rhombus? You got to think about what's special about a rhombus. Okay, so we're going to either need to, somehow first we're going to have to show that it's a parallelogram. So to show that it's a parallelogram, diagonals bisect each other, you said. So what formula will that be? Midpoint formula on the diagonals to show that they bisect each other, to show that they have the same midpoint. So we would do the midpoint of YW and the midpoint of XZ. The midpoint of YW, we're going to subtract the, YW is here and here. We're going to subtract the y's on top, 2b minus 0, over a minus a. Turns out to be undefined, which is what we expected because it's the vertical line here, right? 2b over a minus a is just 0. And then xc, now we're hoping it's a horizontal line because that would make it, no, I did this wrong. I just did slope. And I said I was going to do midpoint. Totally losing my brain here. Yes, it's getting late. Midpoint. Just confused everybody completely. We're doing the midpoints. We're adding the x's, sorry, a plus a over 2. And we're adding the y's, 2b plus 0 over 2. We get 2a over 2, comma 2b over 2, which is just a comma b. And then the midpoint of xy, sorry, I was doing diagonals are perpendicular. I don't know what I was doing. I guess that would be a proof that it was a rhombus anyway. I could do that next. What I was just doing, I could do next. Okay, anyway, xc, we're going to do the midpoint again. So xc, now we're dealing with this one and this one. So we're going to add the x's, 2a plus 0 over 2, and add the y's, b plus b over 2. Again, we're going to get 2a over 2 and 2b over 2. We get just a comma b. So, same midpoint. So the diagonals bisect each other. Therefore, this is a parallelogram. So we've proven it's a parallelogram now. We have to go one step further to show that it's a rhombus. Now, we could do diagonals are perpendicular, right? Because that would do it. Or, like you said, we could do consecutive sides are congruent. So we would have to do distance formula on 2 consecutive sides. So maybe xy and yz. Those are consecutive sides. Distance formula. length of xy, we're doing these two right here. We're going to subtract the x's, a minus 0 squared plus subtract the y's, 2b minus b. That turns into a squared plus b squared, and we keep it under the square root sign. YZ, we're going to do the distance formula again. We get 2a minus a squared plus 2b, or b minus 2b squared. Again, we get a squared plus b squared. Under the square root sign, they are the same, which means that this is a rhombus. Again, you would need to write a sentence that, sort of explains what you did. All right. And okay, so remember you would have to write a sentence here, basically saying since the diagonals have the same midpoint, it's a parallelogram, and since consecutive sides are congruent, it must be a rhombus. Therefore, the segments joining the midpoints of the sides of a rectangle form a rhombus. Kind of just repeat that phrase there. Okay, this one I'm going to let you do on your own because I've run out of time here. I just want to make sure everybody understands part 1 of the test is 1.7, 3.7, 3.8, 6.7. That's all part 1. Part 2 is the 6, 8, 6, 9. Everything we've done in this review session has been part 2, 6, 8, 6, 9. Writing the coordinate proofs with variables. Now, remember, I did another video that is the entire review packet for parts 1 and 2. So a lot of this part 1 stuff, if you have questions on there, part 1 was midpoint and distance formula. If you have any questions on this part 1 stuff, you should watch the video about me explaining the review packet. This is linear equations, point slope form, slope intercept form, vertical lines, horizontal lines, and of course the slope formula. All of that, writing the equation of a line, all of that was in 3.7. 3.8 was parallel versus perpendicular, right? Parallel lines have the same slope, perpendicular lines have opposite reciprocal slopes. And 6.7 was polygons on the coordinate plane, proving that, or showing that something is a rhombus, or is a rectangle, or is a parallelogram, or is trapezoid, whatever. This is using numbers, though. These were with the numbers, not the variables. Okay? Okay, so that's it. Thanks.